archaeologists found 3 stones. They believed that the stones were part of a circle of stones with a community fire pit at its center. They marked the location of the stones K, L, and M on a graph where distances are measured in feet. Find the approximate coordinates of a point at which they should look for fire pit. So we need to find the point which is equidistant from the vertices. So first, if we connect these 3 points, we will have triangle. And we need to find the point which is equidistant from the vertices of this triangle. So let's put that here. We have point P. And this point must be equidistant from the vertices of our triangle. So PM must be equal to PK and PL. So we will use concurrency of perpendicular bisectors of triangle theorem, which tell us that perpendicular bisectors of sides of triangle intersect at point that is equidistant from the vertices of triangle. So first we need to find perpendicular bisectors of sides. So we have to find perpendicular bisector of side LM, MK, and KL. And we know that perpendicular bisector is the segment that is perpendicular to a segment at its midpoint. So first we need to find the midpoints of segments. And it will be enough if we will find only midpoints of 2 sides and they perpendicular bisectors. These 2 bisectors will meet at one point, and the third bisector, perpendicular bisector, will meet at the same point. So I will only find midpoints of KL side and KM, and then I will find perpendicular bisector of these 2 sides, and when I have these perpendicular bisectors, I will find the coordinates of point P. So first I will find the midpoint of KL and KM segment. Let's put that here will be A point, and A will be the midpoint, and here we will have point B. A is the midpoint of KL segment. So we know formula for the midpoint. We need to add first coordinates and divide by 2, and next we have to add the second coordinates and divide by 2. So we will have 2 plus 10 divide by 2, and second coordinate will be 6 plus 2 divide by 2. So point A will have coordinates 2 plus 10 is 12 divided by 2 is 6, and 6 plus 2 is 8 divided by 2 is 4. So we have a midpoint of KL segment. Point A has coordinates 6 and 4. Next, B is the midpoint of KM segment. So again we have to add first coordinates, 10 plus 14 and divide by 2, and second coordinates, 2 plus 8 divided by 2. So point B has coordinates 24 divided by 2 is 12, and 2 plus 8 is 10 divided by 2 is 5. So we have the midpoints of sides KL and KM. Next, we have to find perpendicular bisector of these two sides. And like I said, perpendicular bisector is the segment that is perpendicular to segment at its midpoint. So in my diagram not will be exactly, because we need to have right angle, so A between segment AP and AKL we have here right angle, and PB here we have right angle. We need to find perpendicular bisector. We will find the line which is perpendicular to segment first KL. We will find the slope of KL line, and when we have slope of KL line, we will find the slope of AP line which is perpendicular to KL. And we will find first KM line slope and next PB, because PB is perpendicular to KM. So first we will find the slope of KL segment. Let me remind you formula for slope. If point K has coordinates x1, y1 and L x2, y2, so formula for slope, in numerator we have y2 minus y1, and denominator we have x2 minus x1. So we have slope of KL segment, in other words, is slope of, if we extend segment LK, we have line KL. So slope of KL line will be y2 is 6 minus y1 is 2 over 2 minus 10. So this is equal 4 over negative 8. So this is equal negative 1/2. So we have slope of line KL. Next we will find slope of KM. So the last is M, first is K. So we have first, in numerator we have to subtract y coordinates, 8 minus 2 over 14 minus 10. So this is equal 6 over 4. So this is 3 over 2. We have slope of KL and KM. Because perpendicular bisector we need to find, so we have to find the slope of line which is perpendicular to KL and perpendicular to KM, PB. PB is perpendicular to KM, and PA is perpendicular to KL. So first, let's put that this was 1 and 2. So now we have to find the slope of line which is perpendicular to KL. So again, let's put that KL line is perpendicular to line which pass by point A. So we know that the two non-vertical lines are perpendicular if and only if the product of their slopes is -1. So we have the slope of KL. So let's put that slope of line A is M1 is slope of line A. So the product of slopes KL and line A must be -1. So slope of KL line is -1/2 times M1 must be -1. We have to multiply both sides by -2 to reduce this fraction. So will be -2 times -1/2. 2 and 2 will reduce, and negative times negative give me positive. So we have +1, we don't have to write, we have M1 is equal -1 times -2 is 2. So we have slope of line which is perpendicular to KL line. So we have slope of line A, or we can write AP line. So we have slope of this line. Next we will find slope of line which is perpendicular to KM. So KM line is perpendicular to line B. Let's put that M2 is the slope of line B. So again, the slope of KM is 3/2, so we have 3/2 times M2 is equal -1. We know that two non-vertical lines are perpendicular if and only if the product of their slopes is -1. So now I will multiply by 2/3 both sides to reduce the fraction on the left side. 2/3, of course. So we can reduce 2 with 2 and 3 with 3. So we have M2 is equal -1 times 2/3. So -2/3. We have slope of line B. We found slope of line which is perpendicular to KM and KL. We have one point. We know that this line must pass point A and must be perpendicular to KL. So we will use formula when we have given slope and one point. Let's put x1, y1. The formula for line which pass point which has coordinates x1, y1 is y minus y1 is equal m times x minus x1. So when we have one point and the slope of line, we can find the formula of our line which will pass this point, and which is perpendicular to line KL. First, we will find the line which is perpendicular to KL. So let's put again 1. We have slope 2 and point A has coordinates 6, 4. So we will use this formula. Y we need to copy minus y1 is, this is x1, y1, x1, y1. So we have minus 4 is equal slope of line which passed by point A is 2, and in parentheses we have x minus x1 is 6. So we have that negative 4 we will move to the right side, so we have y is equal, and on the right side we will do multiplication, so we have 2x, 2 times negative 6 is negative 12 plus 4. So we have formula of our line which pass point A and which is perpendicular to KL. Y is equal to x minus 8. And now we will find the line which pass point B and is perpendicular to KM. So we have slope M2 and point B has coordinates 12 and 5. And of course we will use this formula. We have given slope and we have given point. So y we have to copy minus y1 is 5 is equal, slope is negative 2 over 3, and in parentheses we have x minus x1 is 12. So I will move negative 5 to the right side, so y we have on the left side is equal, and I will do multiplication, so it will be negative 2 over 3x. Negative and times negative is positive. 2/3 times 12. 3 with 12 we can reduce, so will be 4. 4 times 2 is 8. And plus 5, because we will move negative 5 to the right side. So we have y is equal negative 2/3 x plus 13. We got 2 lines, and because these 2 lines will cross each other, if we solve these 2 equations, we will find the coordinates of our point P. We will find coordinate x and y. So let me copy these 2 equations. We have y is equal to x minus 8 and y is equal negative 2 over 3x plus 13. We have 2 equations, 2 unknowns. I will use substitution method to solve these equations. So I will substitute y by 2x minus 8, so we will have 2x minus 8 is equal, and right side we will copy negative 2/3 x plus 13. So now I will move the like terms, negative 2/3 x to the left side, so it will be 2x minus plus, of course, we have to change the sign. 2/3 x is equal 13, and negative 8 to the right side, so it will be plus 8. So I will change to fraction. We have mixed numbers. 2x plus 2 over 3, the common denominator will be 3 3, and 3 times 2 is 6 plus 2 is 8. X is equal 21. Next, I will multiply both sides by 3 over 8 to reduce fraction on the left side. 3 and 3 we can reduce, 8 with 8, so we have x is equal 21 times 3 is 63 over 8. And now when we have x, we will find y. I will substitute x in the first equation by 63 over 8, so we have y is equal to, let me copy first, 2x minus 8, so we have y is equal 2 times 63 over 8 minus 8. We can reduce 2 with 8, so it will be 4, so this is equal 63 over 4 minus 8. Now I will change this improper fraction. So this is equal 15 and 3 over 4 minus 8. So y is equal 15 minus 8 is 7, and we have 3 over 4. And let's change 63 over 8. It will be 7 and 7 over 8. So we found the coordinates of P point. X is 7 and 7 over 8, and y is 7 and 3 over 4. So this is my solution. We found the coordinates of point P.